In this lecture, we're going to carry on with our subnetting theme, and by the end of the lecture, you will be able to carry out a variable length subnet mask design for a real-world network topology. Now, it's only a small network in the example that we're going to work through, but you can apply the same things that you're going to learn here to larger networks in the real world. The slide that you see here is the same slide that you saw at the end of the last lecture, where we explained that back in the day with early routing protocols, whenever you did subnetting, each of the subnets had to be exactly the same size. So if you had one subnet that was a /28, for example, they all had to be a /28. You couldn't mix and match /27, /28, /29 within the same larger network. But that ended up wasting a lot of addresses, so with later routing protocols, they did have support for variable length subnet masks, and now we can mix and match the size of our subnets within that greater network. And we're going to work through an example here. The things that we need to consider when we're going to do the design are how many different locations do we have in the network that are going to need subnets, and how many hosts are going to be in each of those subnets. What are the IP addressing requirements for each of the different locations? So should different departments or types of hosts be in different subnets? For example, you might have one office, but within that office, maybe you've got a sales department, a research and development department, and an accounting department, and you want the accounting department to be secured from different departments. Well, in that case, you would definitely put it in its own separate subnet. Because different subnets, we have to route between them at a router, it's easy to secure them at the layer 3 level based on their IP address. And the last question here, what size is appropriate for each subnet? We don't want to waste addresses, but we want to leave some room for growth. So we need to have a bit of a balance here. Don't make it too big, we're wasting addresses, but don't make it too small that we're going to run out of addresses and then going to have to do a redesign later. That would just be giving ourselves a big headache. So for our example, this is our network topology diagram. We've got an organization, they've got an office in New York and a branch office in Boston. New York is their headquarters, and they've got 28 hosts in the engineering department and 14 hosts in sales. In Boston, they've also got engineering and sales. They've got 28 in engineering, the same as in New York, and they've only got 7 hosts in the sales department. So those are the different parts of the network that we need to apply IP addresses to, and we've been allocated the class C network of 200.15.10.0/24 from our internet service provider. Another thing that we need to do is don't forget about our point-to-point links between the routers. They need to have connectivity between each other, so they're going to need IP addresses too. It's a point-to-point link, so we've just got 2 host IP addresses there. The outside interface on the New York router is connected to the outside interface on the Boston router. So that was our requirements. So now we need to think about how are we actually going to design this. And the steps that you work through. First off, find the largest segment and allocate a suitable subnet size for it. You then create that subnet at the start of your available address space. And then that's it. You just keep working your way down. So you start off with the largest subnet, you then move to the next one, the next one, and the next one until you've allocated addresses for all of your different subnets. Now, in a real-world deployment, you want to have a scalable design. So you want to have room for growth in your networking design. So let's say that I've got a subnet that has got 14 hosts on there. Well, you know that one of our subnet sizes is exactly for 14 hosts. Don't give the subnet that size, because maybe in a few weeks' time, a couple of extra people are going to join the department, and now how are you going to fix that problem? So make the subnet size big enough that it's going to be able to grow. Another thing is, because we're going to sequentially go from largest down to smallest, maybe we're going to have a subnet with 30 hosts there, and then another subnet with 30 hosts, and then a subnet with 14 hosts. Well, leave a spare subnet with 30 hosts in it. So don't just do 2 subnets of 30, do 3 or 4 subnets of 30. Because then if you do have a new department that requires up to 30 hosts later, you've got a spare subnet there waiting for it, and everything is still sequential and contiguous, logical, going from largest down to smallest. Okay, so hopefully you got the point there. Don't design for what is right now. Design for what is going to be the best fit in the future. Leave some scalability there, leave some room for growth. So that's what you do in the real world. Don't do that in the CCNA exam. Okay, do not think about, oh, this is what I would do in the real world, this would be best practice. Do exactly what the exam question tells you to do, even if you think that would be a stupid thing to do. Okay, don't overthink things. Don't think, oh, well, it would be better to do it this way. Do exactly black and white what the question asks you to do, and then you're going to get the question right. Okay, so for our example, we had the engineering departments in New York and Boston, and they have got 28 hosts each. And that was the largest subnets that we required. For our example, let's say the exam question says that the departments will not grow and we need to use the smallest subnets possible to maximize our available address space. Okay, so do not leave any room for future growth here, because the question says make it optimal. Maximize the use of the address space. Okay, so that's the question. What I want you to now is pause the video here and calculate the optimal subnet mask for the engineering departments. So no bigger than is necessary, but make sure it's at least big enough to support 28 hosts. Once you've done that, you'll be able to determine the network and broadcast addresses. Do that for both engineering departments, both New York and Boston, and figure out what the range of host addresses will be. Okay, so go on ahead and do that. Please pause the video now. When you come back in a second, I'll walk you through how to get the answer. Okay, so let's look at how to get the answer. So we'd been allocated 200.15.10.0/24. We've been allocated a class C. And we've got 2 different departments that we want 2 different subnets for, and they had got 28 hosts each. A /27 supports 30 hosts. A /28 is 14, so it's not big enough. We can't use that. The smallest that we can use, which is what we were asked to do, is a /27. Real world, you might argue that you'd prefer to use a /26. This is not the real world, it's an exam question. We're going to use the smallest possible, which was a /27. If we wrote that in dotted decimal notation, it's 255.255.255.224. Okay, so that was the first part of the question, figure out the subnet mask. The next thing we have to do is actually divide up our address space. The headquarters was in New York, so let's give them the first subnet. So the network address is going to be 200.15.10.0/27. And if we look at the line, we can see it's after 32. So a /27 is going to go up in increments of 32. So the next network address is going to be 200.15.10.32, which means that the first subnet's broadcast address is going to be one less than that. It's going to be 200.15.10.31. And that leaves addresses available for our hosts of 200.15.10.1 up to 30. Okay, so that's the engineering subnet. Next is the Boston engineering subnet. Well, the last broadcast address used was .31, so the network address we're going to be using is .32. So network address 200.15.10.32/27. Again, we're still using that /27, where the line is after the 32. So the next network address would be .64. So our broadcast address must be 200.15.10.63, which is one less, and our hosts are going to be what's between the network and broadcast address. That's 200.15.10.33 up to 62. Okay, so that was the engineering departments taken care of. All right, that's coming up to the 10-minute mark in this lecture. So if you want to take a break, now's a good time to go and stretch your legs. when I see you back here for part 2, we'll go through the subnetting for the rest of the departments.